Welcome to physics. Currently we are in a chapter measurement, and the topic which we want to study today is micrometer screw gauge, which was invented by a famous astronomer and mathematician, and his name was William Gascoigne. The learning outcome of today's lesson are to understand different parts of screw gauge, to calculate the least count, to identify the zero error, and to use this device to calculate different diameters and to adjust zero error if any. Now, screw gauge is an instrument which is used to measure small lengths, for example thickness or diameters up to 0.01 millimeter or 0.001 centimeter, and this number is called the least count of micrometer screw gauge. Different parts of this device are this part is known as anvil, while this is known as spindle. This is lock. These marks are of the scale which is man scale. This line is known as datum line. This scale is known as thimble scale, while this is known as ratchet. We are going to hold this device with this ratchet, and we are going to spin the ratchet clockwise or anti-clockwise, and by spinning it, this spindle part moves in the forward direction or in the backward direction. When the spindle touches the anvil, this ratchet starts clicking, which indicates that there is no need to apply more pressure on it. Now over here, this 0.25 shows that the smallest value on the main scale is 25, and the largest value is, the smallest scale is 0 while the largest value is 25. If you come here, then the full length of this is from 0 to 25 millimeters. Now here is very important thing. This mark, the first mark is 0, then the downward is 0.5, then this is 1, then this is 1.5, then this is 2, and this is 2.5, and so on. Now further, to find out the least count of this instrument, the formula is pitch of the screw divided by number of division on vernier scale. What is mean by pitch of the screw? It is the distance covered by a screw in one rotation. Suppose it is this screw and you want to tighten it or loosen it, then the distance covered by this screw in the forward direction or in the backward direction will be this much when you rotate it once, and this much distance is known as pitch of the screw. If we have a screw gauge on which there are 100 marks on the circular scale, then in one rotation it will move forward or backward 1 millimeter, and when you calculate this, we get the least count as 0.01 millimeter or this much centimeter. If the circular scale consists of 50 small lines, then in one rotation it covers half a millimeter, and still it gives you this number. So the least count is this. What is zero error? If datum line does not coincide with 0 of thimble scale when the anvil touches the spindle, then there is an error called zero error. Now before using screw gauge, close it by moving the ratchet till the spindle touches the anvil. Then there are three possibilities. Number one, if 0 of the thimble scale coincide with the datum line, then there is no zero error. For example, here this is 0 of the thimble scale, and suppose that this is the datum line, they are exactly coinciding each other, so there is no zero error. But positive zero error, if the 0 of the circular or thimble scale is below the datum line, if you close the micrometer screw gauge and the ratchet start clicking, then this is the situation that the 0 is below the datum line, and in this case the zero error is known as positive zero error. To calculate the positive zero error, the formula is plus n into least count. We know that least count is 0.01 millimeter, and what is n? The number or the mark on the circular scale which coincide exactly with the datum line. In this case it is 4. So 4 into least count gives you 0.04 millimeter. As this is positive zero error, it should be subtracted in the end. Negative 0 error if 0 of the thimble scale is above the datum line. Now this is 0 of the thimble scale which is above. In this case, when we close the screw gauge with the help of a ratchet and it starts clicking, and we see that the 0 of the thimble scale, instead of staying here, it slips up. So in this case the error is negative 0 error. The formula will be minus n into least count, and in this case we are going to count the n from up. That is, it becomes 0, it is 1, and then this is 2. So we take it 2, and the answer is minus 0.02. And in the end we are going to add this value with the main reading to get the accurate answer. Now finding the diameter of different objects with screw gauge. Suppose that we have this screw gauge and we want to find out the diameter of different objects with the help of this. So first step is to find out the 0 error. We see that when both the spindle and the invert they are in contact with each other, then we see that the 0 of the thimble scale is slightly up the datum line. So the error is negative 0 error. And the formula is minus n into least count, and we see that if we count it from 0, then it is 0, 1, 2, 3 and 4. So 4 coincides from upside down. So what we get, 4 into 0.01. So the least count is minus 0.04, and which we are going to remember, or it should be noted with you, it will be used. Now we want to find out the diameter of small bead, which is over here. It is stuck in this screw gauge, and now we are going to read it. The formula to read this is that the main scale reading first, and we see the main scale reading is still here. This 5 shows 5 millimeter, and here is a mark which is 6. So the main scale reading is 6. Now there's a turn of thimble scale reading which is n into least count. Then we see n is the number of the thimble scale which exactly coincide with the datum line. So 40 multiplied by least count. Least count is 0.01 millimeter, that gives us 0.40 millimeter. Now we are going to apply the formula. The diameter of the bead is equal to main scale reading plus thimble scale reading minus and negative 0 error with us. So the main scale reading is 6, thimble scale reading is 0.4 minus, and the 0 error which we calculated is minus 0.04 millimeter. When you this minus becomes plus, you add them all, we get 6.44 millimeter, which is the diameter of this small bead. Now for further clarity, let's do another example. This is my hands-free, and I want to find out the diameter of the hands-free. So I have stuck it here in the screw gauge, and let's read the main scale reading, which is it is 0, 0.5, 1 and 1.5. So the main scale reading is 1.5, and in the thimble scale the number which coincide with the datum line is 45. So 45 is the reading of the thimble scale. So let's put it in the formula. The main scale reading is 1.50, thimble scale is n into least count, which is 45 into 0.01 millimeter, that gives you 0.45 millimeter. Now put it in the formula. It is 1.50 plus 0.45 millimeter minus into negative 0 error, which we have already calculated. So minus minus plus, and adding all these we get 1.99 millimeter. Now going further, here is the wire thicker than the wire hands-free, and this is the wire of the laptop charger. And let's read the main scale reading. The main scale reading shows it 0, 1, 2 and 3. So the main scale reading is 3 millimeter, and the thimble scale mark which coincide with the datum line is 15. So let's put it here. The main scale reading is 3, thimble scale reading is n into least count, 15 into 0.01 millimeter, that gives you 0.15, and put it in the formula. Diameter is equal to main scale reading, which is 3, plus thimble scale, which is 0.15, negative 0 error, which is negative, so minus minus plus, and adding all we get 3.19 millimeter, which is the diameter of laptop charger. I have DELL laptop, that is why I wrote it here. Now the further example, now you want to find out the diameter of solar panel wire. Here is solar panel wire, and let's read this, magnify the scales. So here the main scale shows this 5 is 5 millimeter, 6 millimeter, and this mark shows 6.5 millimeter. And on thimble scale, the mark which coincides here, it is 10, then this is 11, it is 12, so it is 13. So now put the values in the formula. The main scale reading is 6.5, thimble scale is 13 into 0.01, so we get 0.13. Put it in this formula. The diameter of the solar panel wire is main scale reads 6.5 millimeter, thimble scale 0.13, minus 0 error, which was negative in our case, that is minus 0.04, minus minus plus, so adding all these we get 6.67 millimeter. So let's wrap up today's lesson. First, screw gauge can measure diameters and thickness of small objects which cannot be measured with vernier calipers. Least count of this instrument is 0.01 millimeter, that is, it can measure 100th part of millimeter for you, or in centimeter it is 0.001 centimeter. Next, zero error. When zero of the thimble scale does not coincide with datum line, then there is an error in the screw gauge called zero error. Zero error may be positive, it may be negative, and in both cases it should be calculated and noted in advance, which will be used. Number 5, positive zero error is subtracted from the final reading and negative zero error is added. And last but not least, diameter of the object or all the objects which we have calculated in examples, that is equal to main scale reading plus thimble scale reading. Thimble scale reading is n into least count minus zero error. Zero error may be positive, it may be negative. If it is positive, so plus minus it will be subtracted, and if it is negative, so minus minus gives us add, so that is why it will be added in the end. That's it, and kindly don't forget to subscribe the channel and keep watching my